minus px over A. Okay. Now the next one, due to the bending moment, so this is equal to mz over izz multiplied by y. Okay. And when you look at I, is in what? Yes or no? It's minus. And if you look at J and L, they are equal to what? 0, and this will be positive. This will be what? Positive, right? And then if we look at shear, now the shear, how does the shear looks like, okay? If we were to look at the shear induced by, so the shear is induced by Tx over J multiplied by C, right? It will go in this direction. So this is the direction of the shear. And all of them have the same what? Magnitude. Why all of them have the same magnitude? Because C is what? Constant. Is on the what? On the surface. Okay. So all this you will have what? All this you will have dx C over J, dx C over J, dx C over J, dx C over J. Right. So from here, which element are we going to pick to analyze? I, J, K, or L? Yes. Anyone? I. Very obvious. Why I? Because your axial stress or your axial load and the bending moment are going to induce what? Compression. So where failure is going to initiate, this is where failure will initiate. Initiate. It's going to start from there. Are we clear? Okay. So we are really lucky. Why this is important? Okay, why this is important? Because if you look at Tresca, okay, stress yield in tension is also equal to stress yield in what? In compression. Yes or no? This is Tresca. So the yield in tension is also equal to the yield in what? Compression. Are we clear? Okay, for Tresca criteria, like what I told you before, in real life, that's not necessarily true, but it's okay for now. Okay. So now we are going to focus everything onto element E. Okay. Question from anyone so far? Is this clear? Are you okay? Yes? Okay. So the next thing that we're going to do is we are going to consider element I. Okay. So let me get the diagram across. Hey, this is weird. Oh, wrong page. So now, element I is somewhere, it's not somewhere, it's down here. I use a different color. So this is our element I. Okay. So we know if we were to draw our transformation, I know this can be done on computers, okay? I'm working for the fact that we have no power, okay? Justin Trudeau carbon tax, okay? Okay. So only McMaster's engineer can do stress analysis when there's a power failure. So if we were to now sketch how the element will, just a sketch, okay, just a sketch on how the element will look like, okay. So we know if I'm going to sketch an element based on the transformation that we have, right? So this is following this transformation over here. We are aware that we have a what? We have a stress X. And then we are aware that we are having a shear in this direction. Why shear in that direction? Because this is our shear flow direction or our shear stress direction. Okay. So we are also aware that this shear, so the shear, the intersecting plane is X, and then the direction is in what? Is in Z. Okay. And down here, this is shear. Okay, the intersecting plane is Z, the direction is in X. So now we know our direction of our what? The direction of our element. Okay. And now we are going to put in such orientate the element in such a way that we can work with in 3D mold circle. Okay, we're going to sketch this on 3D mold circle. Okay. So before we go on, now we know that we have to determine our stress X and our shear XZ. Okay. And now I would like to orientate our element. Okay, I want to orientate our element such that it looks familiar to all of you. Okay, I'm just thinking which way to orientate. Okay, I'm going to orientate the element such that this is my X. This will be my Z. And this location over here will be my Y. Now, this step I'm teaching you is not necessary unless you design your components with carbon fiber. This is very important. Okay, I repeat again, if you want to design your structure out of carbon fiber, this is where it's critical. So from here, we are going to have our element oriented in such a position now. Am I right to this is my X? Yep. Yep. Okay. So now this is how our element will look like now. Okay. So with that, we know that this is our what? This is our stress X. And then we know that this is our shear XZ. And this is our shear ZX. Okay. So from here, we can now label this as our point Z. This will be our point X. And this will be our point Y. So from here, we can start designing we can start analyzing our 3D mold circle. To determine which plane is tau max going to occur? Right? We have to determine which tau max is going to occur first. Okay. Now, what we are doing now, okay, is of the most value. Later on, the calculation is not straightforward, okay? But if you don't get this concept right, we are screwed, very, very screwed. Okay, so you have to capture this concept well. Okay. So from here, we can sketch our what? We can sketch our 3D mole circle. It's just a sketch. Okay. Now, some of you, so we are going to determine our tau max occur on which plane. Okay. So now we sketch our mole circle. Okay. So this is our normal stress. This is our shear stress. And we are aware that our stress X and our stress Y are on this line. And then we have a stress Z. Okay. So this is our stress Z. And then we are aware that it has shear. Yes. Oh, stress X, you're right. I'm holding you a lot of orange juice this time. So this is our stress X. Thank you. This is our stress Z. Okay. So when we look at our point X, and then we have to indicate our clockwise, and below is anti-clockwise. And if you look at our point X is going to generate a clockwise rotation. Our point Z will generate an anti-clockwise rotation. Then we have our stress average line. And then from here, oh, I think I miscalculated 1 point. I'm going to bring it down. Okay, so over here, this is our point X and point Z. And that is our stress average line. So now we can draw mole circle. Yeah. We can draw mole circle now. Okay. And then this should look really familiar to all of you. And then the next point we have to find out, or we already know, that over here, this is our point Y, right? So to label this is our what? This surface over here is our XZ plane. And our XZ plane, okay, XZ plane happen to be our what? In plane. It happened to be our in plane because it has the biggest what? Surface area, as you already know by now. And then you have the other circle. This belongs to our YZ plane. And the last circle that I'm going to sketch this belongs to our XY plane. Okay. So we have just determined that tau max occur at XZ plane, which is our in plane. Now, why this is important? Okay, so we are going to label this as stress A, and we are going to label this as stress B. So to determine tau max will be equal to what? Stress B minus by stress A, okay, and then we are going to divide by 2.